Hello everyone. So in this video, let us talk about the first three problems from the latest Leetcode weekly contest 277. So let's start. The first problem is count elements with strictly smaller and greater elements. So the problem is very simple. It just states that you're given an integer array nums. Return the number of elements that have both a strictly smaller and a strictly greater number of element appear in the nums. So it just means that for every number you just have to check that whether there's a number that is strictly smaller than that and strictly greater than that is present in there. Now because the constraints are pretty small, as you can see, what you can easily do is that, like, because you have to just find it out, you can just take every number and find out that there's a number that is strictly smaller than strictly greater than that. What you could have also done is, because you initially just sort out the whole array, and after sorting out for every number you just have to check that whether there's a number that is strictly greater than that on the right side and whether there's a number that is strictly smaller than that on the left side. If that appears, then the answer is that that particular number is a valid number, and you have to just increment the count and just print out how many numbers are there actually. Just that's the problem. So I directly take it down to the code part. This is the total how many numbers are there that is following that property. Now this is n, sort out this whole array moving from left to right. False means that till now I've not seen any number that is smaller or greater on the left and right side, so that is false. Now I'll iterate from the current number I plus 1 to till the end, and if I find out any number that is greater than the nums of I, then we'll make a right true that I have found out a number that is greater than the I element on the right side. Similarly, I'll move on the left side and find out, if I find out a number that is strictly smaller than that, I'll make it also true. Now if I find out both on the left and right side the properties that I'm looking for, I'll increment the total and just print out the total. Very simple answer, very straightforward solution. Let's move on to the next problem. Next problem is rearrange array elements by sign. Okay, you are given a zero indexed integer array nums of even length. It's of even length consisting of an equal number of positive as well as negative numbers. So it has this property that is inherited in that problem. Now the problem statement now goes like this, that you should rearrange the elements of nums such that the following conditions are met. The first condition is that every consecutive pairs of integers are of opposite signs. So plus minus, that is fine. Second is that for all the integers with the same sign, the order in which they are present in nums is preserved. So the order is preserved. When you are like forming a new array, the order should be preserved. The third one is the rearranged array should begin with a positive number. So it should begin with a positive number, then it is like positive, negative, and the order should remain preserved. Like you have to return the modified array. Now it's very simple. What you can easily do here is that, because I want to preserve the order, the first thing is preserve the order. Also, it is given in the problem statement that there are equal number of positive and negative numbers. So what you could have done here is that you could have made two vectors or containers to store out the positive and negative numbers. Whenever you see a positive number, insert in the positive vector. Whenever you see a negative number, insert in the negative vector. Just iterate from left to right over that array. Okay. And then what you can easily do here is, let us take the first example, it will make it more clear. So you can just iterate from left to right. You'll see a positive number. You make two containers, positive and negative, and push the positive number in the positive vector and the negative number in the negative vector, so that I have preserved their orders. Now after that, what you have to do is that you have to first print a positive number, then a negative number, positive number, then a negative number. And because the length is same, you will not find out any chance of like overflowing or not. So you just have to print out those numbers in that order. Nothing more complicated, very simple solution. So what you can do is that I have made two vectors of integers, positive and negative. Iterate over this array nums from left to right. Whenever you find a positive number, insert in the positive vector. When you find a negative number, insert in a negative vector. Now what you'll do, you have to print out the final answer. This is the answer vector. Iterate over, like, because I know that there are even number of elements, you could have done to n minus 2. Like you have found out the length of num. So n by 2 are positive, n by 2 are negative. So 0 till n by 2. Now first push a positive number and a negative number. Push a positive number and negative number in both arrays and just print out the answer. Nothing more complicated, very simple solution. The third problem is find all lonely numbers in the array. Okay, so you're given an integer array nums. A number x is called lonely when it appears only once. When it appears only once, that is one of the condition, and no adjacent numbers, that is x plus 1 and x minus 1, appears in the array. So the number should be appearing only once, and no number that is x minus 1 and x plus 1 should also be appearing in that array. If we are talking about that, print all the lonely numbers in the array. That is the whole problem. Now you can easily see that if I'm talking about, let's say, a number that is 2, so 1 and 3 should not be present in the array. So in that case, because I just want to check on the left hand side and right hand side, it's better to just do a sorting operation here. You just do a sorting operation for every number. Just check that the previous number should not be equal to that or should not be less than 1 to that, which means that if the number is 2 and after sorting that out, let us draw it out. So let's say the numbers are like this: 2, 2, 2, 3, 9. Okay, then what you can do is that for the first number, for the left there is no number, that is fine. On the right number it is 2 only. So because, as you have seen here, is because the number should be only occurring once. That's also the condition. So this number cannot be the possible candidate, this cannot be the possible candidate, this cannot be possible candidate, because it is only occurring once. Like the number should be only occurring once. How you can check that? For every number, just check on the left and right side. If the number is on the left or right side are same to this number, then you should not be taking this as a possible candidate. For this 3, if you check on the left hand side and the count or the value of the left number is 1 less than this number, then also this is not possible, because I want that to be a lonely number, and for lonely number, x minus 1 or x plus 1 should not be in the array. Now for the 9, as you can see, on the right there is no number out there, that is fine. On the left number there is a number, but that is way smaller. I just want that it should be occurring only once. 9 is occurring only once, and there should not be a number that is 8 or 10. So there is no number. So this is one of the possible candidates. You have to print 9 in a vector. That's the whole solution. So you just have to first sort it out and do this whole iteration over there. Nothing more complicated. Let's move on to the code part now. So that's what I've done. This is the objective for storing out the answers in the end. This is the sorting part. Move from left to right, that is going fine. Now left and right, we have to just assume true, that our condition is true. But if it turns out to be false, we'll make it false. Now what you're doing here is that we'll first check that whether there's a number that is appearing on the left side. So I minus 1 should be there. The index should be there. It should be greater than or equal to 0. And any of these conditions should be, like, if any of these conditions hit true, then the answer is false. What? If the previous number is same as the current number. So let's say I'm talking about 2, previous, like the left number is also 2, then this is not a valid or lonely number. So we should not be doing anything. So we should be marking it as false, that this is not a lonely number. Or the previous number, I minus 1, is just 1 minus than the current number. So if it is like the current number is 3 and the previous number just to the left of it is 2, then it is also false. So if any of these conditions turns out to be true, then we just mark our left as false, that we have found out a contradiction on the left side. Similarly, on the right hand side, if I plus 1 is inbound and I plus 1 is equal to I, which means that the right element is same as the current element, it is also false contradiction. All the right element is just 1 plus the current element, then it is also a false as thing. You just not be taking that condition. If both of them turns out to be true, then only it means that both of these conditions are satisfied. On the left hand side, right hand side, there is no element that is equal to 1 plus that or equal to that. Then we just have to increment by total. How you can do that? Just print, like just push the current element in the nums vector and just print out the nums vector. That is the overall logic and code part for all the 3 problems. All the code will be in the description of this video. Thank you for watching this video till the end. I will see you in the next one. Till I keep coding, and bye.